In this video, we study voltage divider. We will show these formulas for the voltage V1 applied to the resistor R1 and the voltage V2 applied to the resistor V2. In order to derive the results, we use basic Kirchhoff's laws, Kirchhoff voltage law for the voltages and for currents. Here the two currents I1 minus I2, one goes here and one goes out, equal to 0, so the currents flowing are equal. Now we use Kirchhoff's voltage law. V, the supply, this is DC voltage, equals V1 plus V2. By Ohm's law, this is the product of the current I1 times the resistor R1 plus V2. But we know that I1 equals I2 from here, so it's the same current flowing in the circuit. Plus V2. The current I2 is the voltage V2 divided by the resistor R2 times R1 plus V2. V equals V2 times R1 divided by R2 plus V2. I multiply times R2 both sides, times R2 equals V2 R1 plus V2 R2. I take V2 to be the common factor, and I have R1 plus R2 inside the brackets. I solve with respect to V2. V2 equals V times R2 divided by R1 plus R2. This is the voltage divider to compute the voltage applied to the resistor R2. Again, we use Kirchhoff voltage law. V equals the sum of the two voltages applied to the two resistors R1 and R2. This is the two currents I1 and I2 are equal, so it's I1 times R2. V equals V1 plus, this is the voltage V1 divided by R1 using Ohm's law. I multiply times R1 both sides. From here I solve for V1. So V1 is V times R1 divided by the sum R1 plus R2. Now, if I want to check to verify, I can go backwards and sum the two voltages together, V1 plus V2. I use the formulas for the voltage divider, and this should verify Kirchhoff's voltage law. I can take V, the common factor, and I have two fractions inside the brackets. This is equal to V, assuming that, of course, R1 and R2 are different from 0, assuming that I don't have any short circuit. So if these are some values for the resistors there, I get that V equals V1 plus V2, which is the Kirchhoff's voltage law.